Show by the principle of mathematical induction that for all n belonging to the set of natural number, the expression 10 raised to the power of n plus 3 times 4 raised to the power of n plus 2 added to 5 is divisible by 9. Okay, let us begin. Now here, we do not have to prove that this expression is divisible by 9. Rather, we need to show here that this is a true statement. That means any natural number n that we choose, it's always going to be divisible by 9. Okay, so what we'll do, we're going to consider a statement p of n. Now p of n will be defined such that we have 10 raised to the power of n added to 3 multiplied to 4 raised to the power of n plus 2 added to 5. This particular expression is divisible by 9. So this is our statement and we're going to call it statement number 1. Now in order to prove that this is true for all natural numbers, so what we'll do, we will choose n equals to 1. For n equals to 1, our statement p of 1 will become, we have 10 raised to the power of 1 added to 3 times 4 raised to the power of 1 plus 2 added to 5. So this is going to be equals to 10 plus 3 times 4 cubed added to 5. This will be 10 added to 3 times 64 added to 5. We have 10 added to 3 times 64, that's going to be 192 added to 5. So we have 192 plus 5, so that's 197 added to 10, so that's going to give us 207. Now is 207 divisible by 9? Yes, 207 is definitely divisible by, it's divisible by 9. Well, we know that 9 times 23, that's equals to 207. Now, what we have done here is we have showed here that the statement p of 1 is true. So p of 1 is a true statement. So our goal will be to show that the statement is also true for other natural numbers. So how shall we prove that? So for this, we are going to consider another statement. So let that statement be p of m, such that we have 10 raised to the power of m added to 3 times 4 raised to the power of m plus 2 added to 5. This is divisible by 9, is also a true statement, is true. We're going to suppose that this is a true statement. If this is a true statement, then we can here clearly state that 10 raised to the power of m added to 3 times 4 raised to the power of m plus 2 added to 5, this can be expressed as a multiple of 9. So we can consider it to be equals to 9 lambda, where lambda is simply a natural number. Fine. We're going to use this fact. We'll come back to this in a moment. But what we'll have to do, if we consider Pm to be true, we will use it to verify. That P of m plus 1 is also true. P of m plus 1 is also true, and that simply means that P of m plus 1, the statement must be such that we have 10 raised to the power of m plus 1 added to 3 multiplied to 4 raised to the power of m plus 1 added to 2 plus 5. This expression must be divisible by 9 as well. So this is going to be our goal. Okay, so how shall we show that? Okay, let us begin with the expression. So what we'll do, we will consider the expression 10 raised to the power of m plus 1 added to 3 times 4 raised to the power of m plus 1 added to 2 plus 5. So this is going to be equals to, so we can rewrite the first term as 10 times 10 raised to the power of m added to 3 times 4 raised to the power of m plus 3 added to 5. So this is going to be equals to 10 multiplied to, now in place of 10 raised to the power of m, so what we can do, we can use this expression and we can replace it with 9 lambda minus 5 minus 3 multiplied to 4 raised to the power of m plus 2 added to 3 times 4 raised to the power of m plus 3 added to 5. Okay, so let us further simplify. So this is going to be equals to, so 10 times 9 lambda, that's going to be 90 lambda, minus 10 times 5, so that's 50, minus 10 times 3, so that's going to be 30. So 30 multiplied to 4 raised to the power of m plus 2, added to 3 multiplied to 4 raised to the power of m plus 3, added to 5. Okay, so we have 90 lambda. Next we have negative 50 plus 5, so that's going to be negative 45. Now we can take the second term and the fourth term, and from each of the terms we're going to take negative 3 times 4 raised to the power of m plus 2 as the common factor, which means that in the third term now we'll be left with 10 multiplied to 1. So that's simply 10, minus from the fourth term, since we have already taken out 3 as the common factor and 4 raised to the power of m plus 2 as the common factor, so this will be left with 4. Fine. So this is going to be equals to now 90 lambda minus 45 minus, so what is 10 minus 4? That's 6. 6 multiplied to 3, so that's going to give us 18. So 18 times 4 raised to the power of m plus 2. So that leaves us with 3 terms. Now each of the terms, from each of the 3 terms, if we pull out 9 as the common factor, so we have 9 multiplied to 10 times lambda minus 5 minus 2 times 4 raised to the power of m plus 2. Now, if we replace this entire expression with beta, where we have considered 10 lambda minus 5 minus 2 times 4 raised to the power of m plus 2 to be equals to beta, such that beta belongs to the set of natural number, then what we have done here is we started out by considering the expression 10 raised to the power of m plus 1 added to 3 times 4 raised to the power of m plus 1 added to 2 plus 5. And we're able to show that this is a multiple of 9, which simply means that 10 raised to the power of m plus 1 added to 3 times 4 raised to the power of m plus 1 added to 2 plus 5. This expression is divisible by, this is divisible by 9. And since this is divisible by 9, can we not say that the statement p of m plus 1 is true? Yes, we can say that the statement p of m plus 1 is true. Now, if p of m plus 1 is true, we can generalize it and we can finally say that hence the original statement which we considered to be p of n, so p of n is going to be true. It's going to be true for all values of n belonging to the set of natural numbers. So that means by using the principle of mathematical induction, we were able to show that the expression 10 raised to the power of n plus 3 times 4 raised to the power of n plus 2 plus 5, that is divisible by 9 for any values of n belonging to the set of natural number, meaning any natural number that we pick up, this expression is always going to be divisible by 9, hence proved.